Hi, welcome back to my channel. In this video, I'm showing you how to make a two-way Bluetooth communication between ESP32CAM and Android App, which is from the Flutter. Let's begin. ESP32CAM is not intended for this project. I was looking for something good for the file transfer and found it by chance. Anyway, this project used ESP32CAM instead of ESP32. Since we use the same Bluetooth serial library, it's all the same except for the image part. The overall process is simple. The app requests a picture of the specific resolution through Bluetooth. ESP32CAM takes the pictures and sends data back to the app in chunk units. The app assembles the split byte and completes the original pictures and displays it on the screen. First, I will set up the camera part. ESP32CAM has already been covered in many other videos, so please refer to the video on the upper right if you need more details. I will only bring the necessary parts from the ESP32CAM example. Again, ESP32CAM is not the main part of this project. I will pass by quickly. My ESP32CAM is for the AI Thinker model, so I take this, select one of them for yours. Bring the camera pin information and code for camera initialization. There is nothing to change because it is already defined. This function, setCameraParam, is to change the resolution before taking a picture. This parameter integer has a value of 0 to 4. 4 is the UXGA, which is the best resolution in the OV2640 camera. It's 1600 pixels horizontally by 1200 pixels vertically. The 0 gonna be just VGA 640 by 480. Create a function to capture. Bring the frame buffer right after changing the resolution. If there is a problem with the frame buffer, it will be returned immediately. It also returns even if it's not a JPG format. Always return the frame buffer to prevent memory leakage. Include the camera pin header file that was created at the first, so the camera part is over. Now add the Bluetooth serial library. The Bluetooth serial class has all we need. I will show you how to use callback function instead of getting data in the loop. Let's get the Bluetooth initialization before the camera. Create a function called initBT. Serial BT begins with a Bluetooth device name. If Bluetooth initialization fails, then restart ESP32. The callback function has not been created yet, so empty space will be processed for now. Let's make the Bluetooth callback function. The first parameter indicates the type of the SBP event that has occurred. The second argument is a pointer to a data structure that contains additional parameters regarding the event that occurred. There's a document about SBP API. You can find more information there. First, I'm gonna check for the server open event, which is triggered when a new client connects. When this event comes, let me print a message indicating the client has connected. When a value comes in from a connected client, the event is the data event. From this event, you can check the status, connection handle, length of data, and the data received. The type of value coming from the client is byte. Therefore, it's necessary to change it to its original form. Since I will send the value in string type from app, we need to change it to string first and then change it to a number. This is the easiest way to handle it. You can also send or receive a lot of data using structure. After passing the changed value to the set camera pattern function, it changes the resolution of the camera and starts taking a picture. Also, don't forget to register this callback function in your serial BTE. Let's make a writing function for serial BTE. Serial BTE had already implemented two write functions. You can send a single character as well as unsigned 8-bit integer pointer with size. Also, the frame buffer has unsigned 8-bit integer pointer and length, so we can send it easily. Now you can send the frame buffer before returning it. Okay, almost done. Let me check my code. If the camera cannot initialize, let's restart it. However, the hardware issue cannot be resolved by the soft restart, so it's not necessary. Let's build and check it works. It should be a default without a case. Let's build again. It's working fine as well as you can see on the screen. If there is a problem, you will see a restart screen. It's time to move on Flutter. Please make a project on your side. Android Studio, or VS Code, it doesn't matter. Let's clean up the preloaded dummy code. We don't need this. Also, there is a test folder. Let me delete it. It's very cleaned up. When you create Bluetooth related apps, you always have to prepare the real device. The Android emulator does not support Bluetooth. I connected one in advance. Let's grab the Flutter Bluetooth Serial library. The link is down below in the description. Copy the name of the library and version into your PubSpec YAML. Don't forget to execute pubget after adding any libraries. Okay, now it's available in my project. Starting with make the main function. Import the Flutter library I just added. Weird, it's not figuring out. In this case, go back to the PubSpec YAML and execute the pubget again. It's the only way we figured it out. Let's start with the stateless widget. My app allows you to simply start material app. To execute this my app, the function run app in the main is a starting point. Let's create a stateful widget called homepage. All features will be implemented in this widget. Return to my app and set home to homepage for material app. If you need the details of the Flutter widget, there are many good Flutter tutorials on YouTube. Sorry for not covering all contents. The first thing we need to do is getting the state of Bluetooth on the device. It starts with the unknown state because we don't know what the current state is. Let's create a function that brings in Bluetooth state. The Flutter Bluetooth Serial is a singleton object, so you can use it directly without making an object from the class. Bluetooth state is feature type, so we need to wait until we get the state value from the Bluetooth adapter. The reason why I call the setState function is to redraw widget. Let's create a state change listener to know the current state whenever Bluetooth state changes. The Flutter Bluetooth Serial has already on state change function, so simply use this. When the status changes, it saves the current state and redraws the current screen. This is enough for now. To check what I have done so far, let's draw a UI. Complete the app bar and body parts on the scaffold. App bar shows the basic text about this app, and the body section contains the actual content. I'm gonna create a switch list tile in the column widget to check if Bluetooth is on. This function is called every time the switch is on and off, so you can turn Bluetooth on and off in the app. Also, we need to update the screen when there is an event. This time, this list tile will show you the current status of Bluetooth and move on to the Android setting page so that you can check and pair the detected peripherals. Invoking this open setting function allows you to move the connection on the settings page to Bluetooth at once. To run this app, the Android minimum escape version should be 18. Let's check what we worked on so far. It was built successfully and is currently being installed on the device. I see my real Android device on the right side of the screen. This is mirroring the physical device screen. Currently, Bluetooth is on. Touch the settings button to search for nearby Bluetooth devices. Yes, I see my ESP32CAM Class BD device over there. Select and pair. It's paired successfully. Going back to the app, there's nothing changed. This is because there's no code to show the paired device yet. Let's write a code for this. Create a list to store paired devices. We can grab all paired devices through the getBundledDevices function. After getting the list of the paired device, we need to refresh it as usual. I'm gonna bring a list tile for displaying paired devices for the example source. If you use this, you can print it out neatly. You can download the file yourself or copy and insert the code like me. Let's add a UI code to show the list of the paired devices on the screen. The devices list has all information. With the map, it can be returned to the Bluetooth device list entry we just downloaded from the example source code. Implementing the onTap function so that an event occurs when an item is selected. Okay, let's see how it works. Your app needs this permission because a Bluetooth scan can be used to gather information about the location of the user. Paired device items are now visible. For the test, I cancel pairing of my device and go back to my app. Even though there is no paired device, the app did not update it. Let's handle this part. If you have experience in mobile programming, you may have heard about the app cycle. Generally, there is a callback function that is called when the app goes from background to foreground and vice versa. There is something similar available on Flutter. That is widget binding observer. Include the widget binding observer in the homepage widget and register binding observer in init state. Also, don't forget to remove this in dispose. When Bluetooth is turned on, call this method to get a list of paired devices. Work the same when the Bluetooth state is changed. However, if you turn it off, it will delete all paired lists. We've already included widget binding observer here, so you can use the override function this change at lifecycle state. If the state index is equal to 0, it means your app coming from background to foreground. If Bluetooth is on the state, update the pairing list. Let's check it out on the device. There are currently no paired devices. Let's pair the device. When I come back to the app, I can see the paired device items well. Let's unpair this device and see the list is updated. Nothing is displayed now. It works just as well as I intended. I'm gonna make a new screen called detail page, so sending and receiving data on this page. Import material Dart. This page needs a selected Bluetooth device. So when you create this page from the home page, you have to hand it over to this. Defining the variables needed to make a connection from the paired device. I'm gonna make a function called getBTE connection. This Bluetooth connection returns a connection to the given address. When connected, update the screen and define the function on data received for stream connections. The incoming data is a fixed length list of 8-bit unsigned integers. To use the uint8list class, you have to import Dart type data. When disconnected, the listener undone is called. For debugging purposes, let me print out some text here. Navigate a pop to return to the previous home page. It returns to the previous page even if an error occurs during the connection. Run getBTE connection as soon as you enter this page. Also, you should not forget the dispose. When leaving this page, remove any connected connections. This process is always important. Let's complete the scaffold. App bar adds text that shows the status of the connection. All connection status is connecting, connected, and disconnected. We already have variables to get the status of the connection, so we can easily figure it out with it. If it's not connected, it simply shows the text connecting in body part as well. Let's complete the screen that appears when connected. First, we'll place the drop-down menu including 5 options. Make it easier for users to choose. Select an option and press take a shot button to actually send the request to the connected device through Bluetooth Serial. After the request, the result will be displayed on the black screen. Add a library called drop-down form field. Don't forget to execute popget after adding any libraries. Okay, now it's available in my project. You can create a widget including the data you need for drop-down menu. It's very intuitive and easy to use. Each time a menu is selected, the value is the selected frame size. Easily inserting data in key value type. When it's selected, you can obtain the value. Quickly create the take a shot button. Use the shape to create a red round button. Insert padding to place margins around the text. Let's check what we worked on so far. The paired item has no response when selected. Let's insert the code that goes to the detail page when I press the item. Let's go back to the homepage widget and make a code using navigator push for moving to the detail page. I'm gonna make a function called start camera connect. As mentioned at the beginning of the detail page, you have to put the paired device as a parameter in the detail page. Okay, now we can call this function when the item is selected. Let's build and have a test. Press the paired item here. It's connecting. Now you can see the drop-down menu on top of the device screen as well as the take a shot button. Very nice. Click the drop-down menu and it's showing all the options I put. The button is also pressed well. If your ESP32CAM is still connected in the serial monitor, you can see the console log because the serial BT is connected. From now, let's work on sending string from the app and getting byte array. I will create an asynchronous function called sendMessage. First, I will set the selected frame size variable to 0. Even if none is selected from the drop-down menu, the sendMessage function can be executed when take a shot button is pressed, removing the white space of the text you want to send and allow it to run only when it's at least 1 in length. Encode the text you want to send in UTF-8. In order to use UTF-8, that converter must be imported. Execute the connection output or send method and wait until all of them are transferred. If an error occurs, run the set state to reload the screen. Return to the unpressed of the take a shot button, and if the button is pressed, run the sendMessage function with the selected frame size. Let's complete the part where we get bytes of the image from ESP32CAM. When transferring files, it divides them into chunks and transfers them. What we need to do is we put these chunks together and make it into a complete file. Create a list that can hold all chunks. To know the size of the image, I will create a content length variable. This bytes variable is the space where the image will be stored. When you get an image from the ESP32CAM, on data received is code. All coming data is byte. If the length is greater than 0, add it to the chunks list. The length of the data is also added. After sending a picture from the ESP32CAM, I leave a log to see if the data is really coming in. Let's build and try it. ESP32CAM is still on standby. I press the take shot button here. If you look at the console, you can see the size of the one chunk and how many have been coming in consecutively. You can also check the ESP32CAM console for pattern in, which is 0. This is because the current resolution choice is VGA. And there is one thing I need to point out. The data comes in continuously. In fact, we don't know what the last chunk is. Is the size of the last chunk different? No, there are chunks in different sizes in the middle sometimes. So, as a way of the workaround, I use the restart of a timer. I know this isn't the best way, but it's the simplest way in the current system. It's resetting the 1-second timer each time the data comes in. The function drawImage in order to complete the image is automatically invoked 1 second after the last data is received. In this drawImage, you create an 8-bit unsigned integer list as long as the content and paste the chunks in order. When it completes, redraw the screen and initialize the existing variables for the next images. Go back to the onDataReceived function, call the timer reset when a chunk added. Also, you need to cancel this timer when this page disposes. Let's run and check. The app is up. Select the paired item, it's connecting, connected, take a shot, but nothing comes up. I forgot to add the completed byte image to the UI. Go to the body part of the scaffold. If the byte is not null, the image will be displayed as image memory widget. Fit width makes the image in full width of the source. Let's rebuild and try it again. Select the paired item, it's connecting, connected, take a shot, but nothing comes up. It's getting the data. It works fine. Finally, I can see the image here. One problem is that in the case of the Bluetooth serial, we don't know if the chunk was delivered properly. To solve this problem, we need to manually divide the chunk and send it one by one. And you can see the larger the image, the larger the number of chunks. I'm showing my hand to the camera, but I can see it well because it's dark around me. I will take a picture again in the right of the flash on my phone. Here we go. This time my hand was captured well. The last thing to do is to add a photo view library to add the function to zoom in and out and rotate pictures freely. Also, I will add a simple HUD to let you know if it is currently being requested or downloaded. You can easily complete the photo frame widget based on the code already used above. Enable the rotation and set the minimum maximum zoom and the photo view. To replace image memory with the image provider, simply attach .image at the end of it. That's it. Change this to the frame photo widget. Pop the HUD before sending a message. When the image is complete, showing up the HUD with the message again. Everything is done. Let's try the final version. There is a pop-up HUD for the requesting message as well as the downloaded message. You can zoom in out and rotate the image from ESP32CAM freely. This is the final version of today's video. Of course, there is a lot of room to improve, but let's think this is the minimum version of the project. This is the extra addition. The ESP32CAM is attached to the external battery. I made it very simplest. In conclusion, data communication with BYTE serial is possible and convenient way. However, if you send and receive large files from end to end, you can't guarantee reliability. I reckon I need to study more to make safer and more reliable communication using BYTE serial. That's all for today's video. Thank you for watching. See you in the next video.